Hi. In this third VHDL presentation, we will continue to address register transfer level combinational design issues, and more specifically in this case, the concurrent statements. After watching this presentation, I hope that you will be able to differentiate between concurrent and sequential statements, and also to describe the two main concurrent VHDL statements. Please notice that we will follow chapter 3 of our recommended book. So let me recall that concurrent assignments execute in parallel, as was mentioned in the previous presentation, and that is to say, the order by which they are written is not important. So whenever an input signal changes, all statements that use this input signal are re-evaluated. So everything works as in the case of a hardware schematic diagram, where a given input is connected to various blocks. So if this input changes, it will propagate through the various blocks in parallel. That's the same that happens in the case of concurrent statements. On the contrary, in the case of sequential statements, they are executed in sequence, and so the order by which they are written is important. Of course, you will ask, how do we distinguish between concurrent and sequential statements, besides having different names, of course? Well, the fact is that sequential statements are contained inside a block which is called a process, and it is this process keyword that marks the difference. And by the way, please notice that both concurrent and sequential statements can be used to build combinational and sequential circuits. So it is not true that concurrent statements are for combinational circuits and sequential statements are for sequential circuits. This is not true. Combinational circuits can use both types of assignments or statements, and likewise sequential circuits can also use both concurrent and sequential statements. As indicated in this slide, we will look into two concurrent statements which are called conditional signal assignment and selected signal assignment. Now this slide shows an example of the use of the conditional signal assignment to implement a priority encoder function corresponding to the truth table shown on the right. The code is again very much self-explanatory, so basically what is required here is to get acquainted with the syntax of this type of statement, and that of course will come only from practice. But please go to pages 41 to 44 of the book and read carefully the explanations that are presented there. You should notice also that exactly the same function can also be implemented using the other concurrent statement called the selected signal assignment, and this is what is shown in this slide. The syntax is of course different, but the end result will be the same from the functional point of view. There will of course be differences in terms of the structural implementation, meaning that these two concurrent statements, even when implementing the same logic function, may lead to implementations that require different numbers of FPGA resources, and therefore may have different speed and power consumption values. It is then the designer's responsibility to find out what is the best option for each specific design, and that judgment comes, of course, only from experience. Again, please go to the appropriate pages in the book, which in this case are pages 44 to 46, and read the explanations concerning the implementation of this priority encoder, now using the selected signal assignment. Thank you for your attention.